Hello everyone and welcome to my YouTube channel. So today we are looking at our first video on the breakdown, and then we are focused on the OSI model because that's how Wireshark will break packets into the various layers for us to understand. So starting from the first layer, we have the physical layer, which where the frame lies, and then all that we have is the physical interface on our node. So we have the interface ID. This traffic was captured on a Linux device. And also we can see the encapsulation is Ethernet. So the next layer above the physical layer is the data link layer where Ethernet operates. So in the Ethernet header, we can have a look. Credit to Jeremy's IT Lab for this beautiful presentation. So in the Ethernet header, what it does is that it provides node-to-node connectivity between devices, switch to PC to switch, and switch to router. And then also we have a lot of it checks. It also has the detects and corrects physical layer errors. So that's the frame check sequence over here. The purpose of the frame check sequence is to make sure that there is no corruption. And in Wireshark, the frame check sequence is not captured because the frame check sequence is not it's not being passed to it's not being passed to Wireshark. I mean, it's just a checksum when the frame is sent across the wire. The frame check sequence will just make sure that the checksum against every bit or byte is well contained in the packet, right? So we also have the preamble, and the preamble is responsible for setting an end-to-end bit synchronization between the destination and the source MAC address. And then we also have the start of frame delimiter. So it indicates that the first bit after the start of frame delimiter is when the frame is starting. And then we have a 6-byte MAC destination address and then the source MAC address. Okay, so with the destination address, we can check from here. It's a 6-byte, and as you can see, when we click on it, you see the first byte. As you can see over here, you see it starts from 08 to all the way to, okay, let me click on it again. So 08, and as you can see, 08, 00, 27, E4, 9F, 6B, that's the hexadecimal. So that's the 6-byte destination MAC address. And then we also have the source MAC address, which is also a 6-byte figure. And then we also have the type. And the type is a 2-bit frame. So what the type does is that it specifies the next layer above the Ethernet layer. So it can be an IP packet, it can be an app, or it can be an IPv6. And then what we are looking at is 0800, which is a typical of IPv4, right? That's for IPv4. So now we know that the next layer above the Ethernet layer is the IPv4 protocol. And as you can see, if I am to expand, you are going to see that here we have the IP header over here. So this is an IP, as I said, a typical of an IPv4, which is part of the Ethernet frame, and it lies on top of the source MAC address. So from the destination, this is our source MAC address, and then we add the IP because remember, the IP address will be resolved to MAC address on the local network segment. So what else we can do is that we can filter for non-ether traffic. So I'll go to right click, and then I'll go to prepare as filter, not selected, and I'll click on enter. And as you can see, the next one we have is we have the broadcast, right? It's an app, so it's an app packet, and as you can see, it's 0806, and then we had IPv4 as 8000. So we can have a lot. You can also have IPv6. Let me scroll to the packet. I'm not sure I have IPv6. So that's all for the Ethernet frame, and then see me in my next video for the IP header conversation. Thank you.